Hi there, today I'm going to be showing you how to add and subtract like terms. So we're going to start with this example here. And when we add and subtract like terms, we like to classify like terms as the terms with the same variable and the same degree. So let's say if we look at 2x, 2x is the same, we can see that this is a like term with 3x because 2x and 3x both have an x at the end, like this. Same for, say, x cubed and negative x cubed and x cubed. Both like terms because they both have an x raised to the exponent of 3. Same for y and positive 6y. These are also like terms. And the constants are also like terms too. So these have no variables. This has no variable. So these are also like terms as well. Alright, so we're going to start adding these like terms together. We're going to combine them first. So to combine these like terms, we look at the terms that are similar. So 2x is similar to 3x because they both have an x. So we're going to write 2x and plus 3x. Remember to consider the sign in front of it, so we're going to write plus 3x as well. Okay, next step, let's look at negative x cubed. So let's combine this, okay? Remember the sign in front of it, the negative, we must write that. Think of each number with each term with a sign in front of it. So for 2x, there is an invisible plus sign in front of it. So here, there's also an invisible plus sign. But usually mathematicians don't write that, so yeah. And also, terms are separated by signs. You will notice that. So we have how many terms here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 terms. Anyways, back to what we were doing. So we have negative x cubed, so we write that here. And we also have positive x cubed. They're both very similar. They both have x cubed. So we're going to write that here. And we circle that. And then we write, let's look at the constant, 3, so we have to include the sign, so plus 3, and negative 9. So we're going to write that in as well. Circle everything we write into the next line. Then we also have negative x squared, don't forget the negative. And we also have positive y and positive 6y. So we put the y's together. So this negative x squared, there's no other like term for it, so there's nothing to add to it. So let's see. So we have this as a like term, as like terms, and these together, these constants, right? They don't have variables, so they're called constants. And this is by itself, it's the only x squared. And then we have these as well, the y's. So now let's add them together. So 2x plus 3x. So it's like saying 2 plus 3, except we just add an x. So we just add the x and we say 2 plus 3 is 5, so we write 5. And then here, negative x cubed plus x cubed. So it's like you're subtracting something and then you're adding something back. So if I take away $4 and then I get $4 back. So let's say I take away $4 from someone and I give them $4 back, so it kind of balances out. So this would be 0, so you can cancel these. It's just going to be 0. So 0x cubed. You could write it as 0x cubed for now. And then 3 minus 9 would be negative 6. If you look at the number line, be negative 6. And then this would be negative x squared. And then we have y plus another 6y. It's like we're saying, so this y has like an invisible coefficient of 1 in front of it. So it's like we're saying 1 plus 6, except we have to put the y at the end. So that would be 7y. And then here we don't really need to write 0x cubed. It's 0, so we can just omit that. And there we have it. But we should probably arrange this in descending powers of x. So if you were to do that, we would rewrite negative x squared first because we want to descend the powers. So this is the bigger power, and then we write the next power, so 5x. And then let's write the constant at the end. I don't think it really matters, but let's write the constant at the end. It looks better. So positive 7y, we're gonna get rid of this. And then minus 6. See how when I copy these terms, I have to consider each sign in front of it? The 5x has an invisible plus sign, so I had to copy that in front of it right here. So this is the first example. Okay, let's look at another problem now. So this one is a little bit more challenging. We can see that like terms, well, let's see, what are some like terms here? Oh, the x cubed and the x cubed here, they're like terms. We also see that we have some x and y's, they're all mixed together. And we also have constants too, so we can right away say that these constants are like terms. And we can also say, oops, this should be included. This whole thing and this whole thing are like terms because they both have x squared y. X squared y. So that specifically, the exponent to the x is 2 and the exponent to the y is 1. Well, it's invisible. It's usually not written, but it's there. So y to the exponent 1. But do not confuse these terms with xy squared. This is also another term. It's a like term to this term, xy squared. They're two different things. Notice that the exponent to the y is 2 and the exponent to the y is 1. The exponent to the x is 1. The exponent to x is 2. So this has x to the exponent 1 and y to the exponent 2. X to exponent 1, y to exponent 2 for this one as well, these ones in triangles. So they are not the same as the ones in the box. And what else do we have? Well, we don't have any more like terms that can be really combined, but we have like terms that we need to combine in this question. Okay, now we are going to start working on the question. So let's look at 12x to exponent 3. We're going to copy that. And then we also have, we do have a like term for it. Positive x to exponent 3. So we're going to write that down as well. So we circle what we write. And then let's just copy negative 2x for now. We don't have any other like terms of x. We have positive y, so we're just going to write positive y and positive 3y, so we don't have other terms of y. Do not confuse it with these other terms, okay? Their exponents are different. They have this one, say it has x added to the y with it together, multiplied together. So we cannot say that this term is a like term to 3y because this only has y, while this has an x with a y, so we cannot say that they're like terms. They're unlike terms. And then let's see, we also have negative 2xy squared, so we're going to write that. And this has a like term, as mentioned before, negative xy squared. They have the same exponents to the same variables. So these are like terms. And these are like terms. And then we also have 3x squared y. Positive 3x squared y, remember the sign, and negative 2x squared y. So always consider the sign in front of the term, this sign right here. So we have that, and then we have to, these are like terms. Then we have constants, so negative 1 and positive 4. So negative 1 plus 4. And lastly, we have negative xy. Okay, and we should write that these are like terms. Okay. Let's see if we got the right number of terms. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. A great way to check is to count the number of terms in this resulting line in comparison to the question. Okay, so now let's combine these terms. So 12x cubed plus x cubed, well, it's just like saying 1 times x cubed. There's an imaginary 1. So 12 plus 1 is 13, and we just add the variable at the end. Okay, and then we got these done. Now negative 2x is just negative 2x plus 3y plus 3y. These are not like terms. And then we have this. So we consider the coefficients in front of it. So we consider the negative 2 and this negative xy squared. Well, there's an imaginary 1 in front of it, so it's like negative 1. So negative 2 minus 1, so you take away 2 and you take away 1, so it's 3 being taken away in all. It's negative 3xy squared. And then we also have 3 minus 2 because we just consider the coefficients. 3 minus 2 is 1. And then we write the variables, just copy the variables at the end, x squared y. And then we have negative 1 plus 4. So it's like saying 4 minus 1, which is going to be 3. And then we have negative xy. Okay, and let's rewrite this. We don't need to write the 1. We should simplify that. So let's not write the 1. So I'm going to copy everything. Okay, and normally we write the greater powers at the front, so let's do that. So I'm going to write this, and I'm going to write this. Doesn't really matter, but it looks better. And the constant usually goes at the end. Then this. So greater powers at the front. Oh, oops, I should have wrote negative xy somewhere here. Didn't. But that's okay, it doesn't really matter. Or it could be fit in between. Usually I see it like this. Let's rewrite that. So I'm just rearranging these terms. Okay, so there we have it. This is the simplified expression, and that's the end. Thanks for watching.